Hello students, so today you are going to learn new point from the lesson acid, base and salts from class 10th. So this is the point, how do acids and bases react with each other. So today you are going to learn this point. Here is the small activity 2.6. Take about 2 ml of dilute NaOH solution in test tube and add 2 drops of phenolphthalein solution. What is the color of the solution? Here you can write color changes to pink. Next, add dilute HCl solution to the above solution drop by drop. Is any color change for the reaction mixture? Yes. Here you can write yes. Pink color, what is the answer then? Pink color disappears after addition of HCl solution. This is the answer. Next is, why did the color of the phenolphthalein change after the addition of an acid? So the reason is, this change happens because HCl is an acid which react with NaOH, which is base, and neutralizes its effect. Next, now add few drops of NaOH to above mixture. Does the pink color of phenolphthalein reappear? Again answer is yes. So when you add NaOH solution in the above few drops of NaOH in the above mixture, then again pink color can appears. Why do you think this has happened? So the answer of this question is because after addition of few drops of NaOH, the above mixture becomes basic, and in basic solution phenolphthalein changes its color to pink. So in this way, in above activity, we have observed that the effect of base is nullified or neutralized by an acid, and vice versa. Vice versa means the effect of acid is nullified by the base. This reaction or the reaction taking place is written as, here you can see NaOH aqueous in solution, then hydrochloric acid. These two are the reactants. NaOH plus HCl gives NaCl. Now this one is the salt or aqueous solution of the salt of that metal, and then water H2O. So this is the reaction. So when this NaOH is the base, here you can see NaOH is the base, hydrochloric acid is acid, and this is the salt. So when base and acid react with each other, there is a formation of salt and water. So this is somehow it is a neutralization reaction. Next point is the reaction between an acid. Here you can see the reaction between an acid and base to give a salt and water is known as neutralization reaction. And in general, neutralization reaction can be written as base plus acid or acid plus base. It gives salt plus water. So this is the neutralization reaction where an acid and base react with each other to form salt and water. The next point is reaction of metallic oxides with the acids. So before that you have learned metal react with the acid. This is the chemical property. And now you are going to learn how that metal oxide react with the acid. Again, here is the small activity 2.7 where you have to take small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. Note the color of the solution, that what has happened to the copper oxide. Now here you can note down the molecular formula of copper oxide is CuO. This is the copper oxide, and this hydrochloric acid means HCl. So when this reaction takes place, it gives CuCl2. Once again I will write here properly. Copper oxide CuO plus H2O, sorry, not H2O, it's HCl, hydrochloric acid, gives CuCl2 plus H2O. Now here you can write H2O liquid. This is liquid. This CuCl2 is aqueous. Copper oxide is solid and hydrochloric acid is also aqueous. Now, so what happens here? So when copper oxide react with the hydrochloric acid, actually this copper oxide is black in color, and the color of the solution turns green, and copper oxide is the black in color. It reacts with the hydrochloric acid to form copper chloride. This is CuCl2 means this is the copper chloride. Copper chloride is brown, but it absorbs water and turns the solution into a green color. So copper chloride, this copper chloride is brown in color, but when it absorbs the water, it turns the solution green in the color. Here it is given, you will notice that the color of the solution becomes blue-green and the copper oxide dissolves. The blue-green color of the solution is due to the formation of copper second chloride in the reaction. The general reaction between the metal oxide and acid can be written as metal oxide plus acid is equal to salt plus water. So here metal oxide when react with the acid, you have to note down this. Metal oxide when react with the acid, it gives salt of that metal as well as water. Hope so you have understood the reaction of metallic oxides with the acids. The next point is here, from that point which is given. Now write and balance the equation for above reaction. Since the metallic oxides react with acids to give salt and water, similar to the reaction of base and acid. Metallic oxides are said to be basic oxides. So this one is, you have to note down, the metallic oxides are said to be basic oxides because the reason is what is the reason behind it? Because metallic oxides are, why they are called as basic oxides? When metallic oxides react with the water and when you dip the red litmus paper, it turns blue in color. So that is called it as also said to be basic oxides. Now the next point is reaction of non-metallic oxide with the base. Now how metal react with the acid? In the same way, here non-metal react with the acids and they produce the non-metallic oxides. Now here the reaction of non-metal oxide with the base, how it takes place. So what is given here? You saw the reaction between carbon dioxide and calcium hydroxide. Calcium hydroxide is also called as lime water. You can note down lime water means calcium hydroxide. In activity 2.5, calcium hydroxide, which is base, react with carbon dioxide to produce salt water. Since this is similar to the reaction between base and acid, we can conclude that non-metallic oxides are acidic in nature. So from here you can understand that calcium hydroxide, which is a base because it has a hydroxide group. So this calcium hydroxide, which is base, it can react with the carbon dioxide to produce salt and water. So this reaction is similar to the reaction between base and acid. So we can conclude that non-metallic oxides are acidic in nature. Next point is, what do all acids and all bases have in common? Here you can see in the section 2.1, we have seen that all acids have similar chemical properties. What leads to the similarity in properties? We saw an activity 2.3 that all acids generates hydrogen gas on reacting with metals. So hydrogen seems to be common to all acids. Let us perform an activity to investigate whether all compounds containing hydrogen are acidic. So here the activity is given. We will read first activity. Take solution of glucose. Now in this activity, what you have to take? Solution of glucose, alcohol, hydrochloric acid and sulfuric acid. So this type of solutions you have to take. Then fix 2 nails on cork. Here you can see what type of solutions are taken here. Glucose, alcohol, hydrochloric acid and sulfuric acid. So here in the diagram, dilute hydrochloric acid is taken, and the second point is fix 2 nails on a cork and place the cork in a 100 ml beaker. So this beaker is 100 ml, and this one is the cork. We have seen this cork, where on the cork 2 nails, this one and this one nail is fixed. So this flask or this beaker is of 100 ml, where at the center of the beaker cork is placed with the 2 fixed nails. Now connect the nails to the terminals of 6-volt battery through a bulb and switch as shown in the figure 2.3. So you have to connect the nails to the terminals. This nail is connected to the another terminal of the battery, and this nail also connected to the one end of the battery. So here you can notice that now these connections are done. Now pour some dilute hydrochloric acid in a beaker and switch on the current. So here you can see the dilute hydrochloric acid is used, and when current is switched on, at that time some reaction takes place in the beaker. So repeat with the dilute sulfuric acid. Same reaction you can repeat with the dilute sulfuric acid. Instead of hydrochloric acid, second time you have to take dilute sulfuric acid. Then you have to observe. What do you observe? You have to start your observations. Repeat the experiment separately with glucose and alcohol solution. Then again same experiment you have to repeat with the glucose as well as alcohol solution. So first you are going to do with the hydrochloric acid, then the sulfuric acid, and then the glucose, and then the alcohol solution. So what do you observe now? Does the bulb glow in all cases? This is your question. So you have to check whether the bulb is glowing or not in HCl, whether the bulb is glowing or not in the sulfuric acid, whether the bulb is glowing or not in alcohol, and as well as in glucose. So you have to check all those things. So what will be your observations? So here I will tell the all observations to you. So first observation is acid ionizes in water solution to give H plus ions. As a result, ions are freely available in water to conduct electrons. to conduct electricity. As a result, bulb glow. So here in the acidic solution in HCl as well as in sulfuric acid, here you can notice in sulfuric acid and in HCl this bulb can glow. But if you see the second observation for the glucose and alcohol, so the bulb will not glow in the case of glucose and alcohol. So here you can see in the case of this glucose and alcohol, this bulb will not glow. What is the reason behind it? So here, as this alcohol and glucose, these are the organic compounds. This alcohol and glucose are the organic compounds. They do not ionize in water. As a result, such a solution does not conduct electricity. So in this way, only in hydrochloric acid and in sulfuric acid bulb glows, but in glucose and alcohol bulb does not glow. So here the last question is, does the bulb glow in all cases? So here in all cases bulb will not glow. Only in acidic solution it can glow. So this is the observation of this activity. So here you have understood the point, what do all acids and all bases have in common. So hope so you have understood here. The bulb will start glowing in the case of acid, as you have seen in the figure. So the next point here it is some observations, as I told you from the activity is given here. Once again we will read. The bulb will start glowing in the case of acids as shown in the figure 2.3. So here we have seen this, but you will observe that glucose and alcohol solution do not conduct electricity. Glowing of the bulb indicate that there are flow of electric current through the solution, and the electric current is carried through the acidic solution only. So through the acidic solution only electric current can be carried. Acid contains, now why from acid only? So here the answer is acid contains H plus ions, and these H plus ions means as a cation, and anion such as chlorine minus in HCl, NO3 minus in HNO3, SO2 SO4 2 minus in H2SO4, then CH3COO in CH3COOH. So like this way some cations, ions and anions are present. Since the here you can see the cation present in acids, cation present in acids is H plus. This suggests that the acid produce hydrogen ions, means H plus ions it can produce in the aqueous solution, which are responsible for their acidic properties. So because of this H plus ion, these H plus ions are responsible for the acidic property of that substance. Repeat the same activity using alkali such as sodium hydroxide, calcium hydroxide, etc. What can you conclude from the result of this activity? So again same activity you have to repeat by using some alkali such as sodium hydroxide and calcium hydroxide. Why? Now sodium hydroxide and this calcium hydroxide is a base, but they are called as alkali because they can dissolve in the water. That's why they are called as an alkali.